Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are going to continue talking about imaginary numbers. We started that last time, and we said the imaginary number, we call it I, is the square root of -1. And now we are going to see where can we see that in our work. So before discussing that, probably let me talk about polynomials. If I'm graphing a polynomial, the easiest polynomial we know of is the straight line, right? Y equals mx plus b, the x power is 1, straight line. Straight meaning it doesn't have any curvature, right? Good. What if we go a step further and say, let's talk about quadratics. Ax squared plus bx plus c. When I plot it, I get a parabola opening up or down. But you see the parabola? It turns once. So it's going down, then up, or up, then down. That's it. What if I make it a degree of 3? I can see that some graphs may go down, then up, that's one term, then down again, that's 2. Or down, or up, then up, also twice. It changes direction twice. And if you try quartic equation, meaning a degree of 4, you cannot have more than 3 turns. Oh, 4, 3, 3, 2, 1, 0. Oh, so the maximum number of turns a polynomial can have, a polynomial graph can have, is 1 less than the power, than the degree. Exactly. Today we are going to talk about quadratics because you already did that in Algebra 1. They are easy, and then we'll build on that later. Quadratic equation in its standard form or a quadratic function looks as ax squared plus bx plus c, right? If you equate it to 0 and make it an equation and you graph this equation, you will get 2 possible scenarios. In fact, there are 6 possible scenarios, but I mean, as families, you get 2 families here. One of them is for a greater than 0, and one of them for a less than 0. A greater than 0, I'm sorry, the parabola is opening up. A less than 0, the parabola is opening down. Okay? Okay, so far so good. But that's not the whole story. If you look at the solution, when you equate that to 0 and solve for x, we learned that x equals -b plus or minus the square root of b squared minus 4ac over twice a. So just b squared minus 4ac, which is the quantity under the radical, we refer to that as the discriminant, because it discriminates between 3 possible cases. And for simplicity, because I'm not going to write this horrible word like 6 times, just going to say D. Here, D is greater than 0. Why? And when D is greater than 0, you get 2 possible answers. But you can think of another parabola that may look something like that. It goes down, barely touches the x-axis, then goes up again. In this case, D equals 0, and you have a unique solution. In fact, it occurs twice, but it's the same number because you had a perfect square. For example, you had x squared minus 6x plus 9 equals 0. So when you solve, you get x minus 3 quantity squared equals 0, meaning x minus 3 is 0, plus or minus 0, right? So you get x equals 3 or x equals 3. It's the same number. But don't you see that I may get a case where the vertex of my parabola is above the x-axis when it's opening up, in which case d is less than 0, and I have 2 imaginary solutions. That's the meaning of imaginary. It doesn't cross the x-axis because crossing the x or touching the x is the solution. So no solution. We used to say no solution. Now we are going to say two imaginary solutions. And imaginary solutions in polynomials always come in pairs. I cannot have just one. How can you plot a parabola with only one imaginary solution? It's impossible, right? If it has one, then it's going to go up, so it will cross. If it has one, so again, here D is greater than 0. I have two solutions. And again, I may have a parabola that barely touches and comes back down, in which case I have a unique solution and D equals 0. Or the vertex is below the x-axis and it's opening down, as we said, and here we have D is less than 0. When I have a polynomial of degree 5 or 6, you see it may have 4 terms or 5 terms, but the imaginary numbers can either be none or 2 or multiple of 2's, because it never comes singly. So 2, 4, 6, and so on and so forth. Okay, so that's quickly a quick breakdown of the scenario that we have. So when we look at these problems, and there are 10 of them, I don't think I'm going to do 10, so maybe I'll do the left 5. And I'm going to use this page because I don't have enough to explain the solution. The first one said the solution to the equation 4x squared plus 98 equals 0 is one of those. First of all, we had to subtract 98 from both sides, right? And then we have to divide by 4 both sides. So I get x squared equals negative, and of course I can simplify by 2 and by 2. So I get negative 42 halves. Then I'm going to take the square root of both sides, and always be careful. You have to say plus or minus, because if x squared, it means it has two answers. You cannot just say the square root of negative 49 over 2. Okay, left-hand side is x. Right-hand side is plus or minus. You know that if you have the square root of a over b, you can simplify it by saying the square root of a over the square root of b. So I'm going to say equals the square root of negative 49 over the square root of 2, which is plus or minus. I'm going to break that down in the beginning. After that, you will do it automatically, but I'm going to say it's the square root of 49 times the square root of negative 1 over the square root of 2. This guy is called I, and the square root of 49 is 7. So I say it's equals plus or minus 7i over square root of 2. None of these equal that. Why? Because I have an irrational denominator. How do we solve that? You multiply top and bottom by that irrational number. And if it were, plus 3 plus square root of 2, you multiply by 3 minus square root of 2 over 3 minus square root of 2. So you take, if it's just a square root, you multiply it by it to get rid of it. If it's square root plus or minus a number, you multiply by minus or plus that number. Okay? So you get plus or minus 7 root 2i. Root 2 times root 2 is 2. And that is number 4. Okay, let's do the next one. In fact, let's plot that and see. Let's plot 4x squared plus 98. Notice that when x is 0, y would be 98. So you have to adjust your window. I will take the window, I'll take maybe -5, whatever. It doesn't matter, 10 or whatever. Um, so we said the minimum would be 98. So let's say even 80, whatever the minimum. And let's make that a large number, 300 or something in graph. Do you see what's going on? This number is 98. When x is 0, it's 98. So it's this case right here. It doesn't cross the x. That's why you get imaginary ends. It's just, we don't need to do that. I'm just showing it to you. So that was number 50. This is number 51. What is the solution of the equation wx squared plus w equals 0 is solved for x where w is positive? Why do they say that? Because if w is negative and you move it to the right, it becomes positive and you won't get any imaginary answer, right? So let's subtract w from both sides and then divide by w both sides. And you get x squared equals -1. So x equals this plus or minus the square root of -1 equals plus or minus, equals plus or minus I. Again, number 4. Let's try number 52. The roots of the equation x squared plus 2x plus 5 equals 0 are. I see that, well, we can say here a equals 1, b equals 2, c equals 5. So x equals -b, which is -2, plus or minus the square root of b squared, which is 4, minus 4 times a is 4 times c is 20, over 2 times 1 is 2. So you get -2 plus or minus the square root of -16 over 2 equals -2 plus or minus. Remember what we said, square root of 16 times square root of -1 over 2. This is 4, this is I, so I get -2 plus or minus 4i over 2. Both are top and bottom I can be simplified by 2, and you get -1 plus or minus twice I. Yeah, it's number 3 this time, right? Okay, number 53. The roots of the equation x squared plus 6x plus 10 in the simplest form is. By the way, this can be, you can use the quadratic formula like we did here, but in both cases, I can do it something else. I can complete the square. Do you know that I can write this as x squared plus 6x and then leave the 10 out? And then I say to make it a perfect square, meaning I divide this by 2 to be 3, meaning I will get x plus 3 square here. But in order to do that, I have to add 3 square, which is 9. But if I add 9, I have to subtract 9, or else the problem would be wrong. Right? I added 9, subtracted 9. I added 9 to make that a perfect square. I subtract 1, so I get plus 1 equals 0. Then I can subtract 1 from both sides and get x plus 3 squared equals -1. I'm going to take the square root of both sides after adding that. Notice this guy is I. So I get x plus 3 equals, oh, I'm sorry, I have 2 pluses. X plus 3 equals plus or minus I. So x equals negative 3 plus I, or x equals negative 3 minus I, which is number 3 again. I could have used the quadratic formula. It's both same thing here. I can use the quadratic formula right away. That's easy because let me do it also with the quadratic, so I show you something that some students have trouble with. X squared minus 4x equals negative 13. Here, I'm going to say, okay, if I divide negative 4 by 2, I get negative 2. So eventually, I will end up with that. Okay? But what do I need to add here? Of course, 2 squared, which is positive 4, right? Do you see what we did here? We added 9 and we subtracted 9. Why? Because they were on the same side of the equality. You have a scale. You add 9 and then you subtract 9. So it became equivalent again. Here, I added 4 to the left-hand side. So I add 4 to the right to make them even. So either I subtract 4, which doesn't make sense because I'm going to move it to the other side, or say plus 4 to both sides. I didn't change anything. I added 4 to the left of the equality. I added 4 to the right of the equality, in which case I will get negative 9. Then I will take the square root, adding a plus or a minus. This with the square will cancel, so I get x minus 2 equals plus or minus square root of 9 times square root of negative 1. Notice when I see that, I know it's 3i right away, but I'm taking it step by step with you so you make sure you understand what I'm doing, and then you will do it yourself easily. I'm going to add 2 to both sides, and I get x equals 2 plus 3i, or x equals 2 minus 3i, which is number 1. And finally, on this page, number 55, I have negative 1/2 x squared equals negative 6x plus 20. I think it's better to multiply by 2 both sides, or by negative 2 even. So I get negative times negative is positive, 2 times 1/2 is 1, so I get x squared equals negative 2 times negative 6 is 12x, negative 2 times 20 is minus 40. Then I'm going to subtract 12x and add 40 to both sides, or I could have left the 40 like we did here. It's really up to you. So I get x squared minus 12x plus 40 equals 0. Why do I do that? Because I want to complete the square. If I divide negative 12 by 2, it's negative 6. So I know this will end up being x minus 6 squared. But after dividing it by 2, I have to square, so I have to add 36 here. And I can subtract 36 from that or add 36 to the side. Notice that's why I said there is no reason to bring the 40 because I'm going to move it back. And I'm going to say subtract 40 from both sides. So it won't be confusing to moving it to the left and to the right. Just leave it on the right-hand side. I just wanted to show you what happens here. I get negative 4. I will take the square root of both sides. Don't forget to say plus or minus. So this and that cancel each other, and I get x minus 6 equals plus or minus square root of 4 times square root of negative 1 equals plus or minus 2i. So x equals, adding 6 to both sides, 6 plus 2i, or plus or minus 2i, right? 6 plus or minus 2i is number 3. Notice that this one is negative 6 plus 2i, but no, I have positive 6. Then two quick uh, questions. They won't take us 5 seconds. In fact, I'm not going to solve them. It tells you which graph shows a quadratic function with two imaginary zeros. Is it 1, 2, 3, or 4? You tell me which one. Said 2, you are perfectly right. If you said 3, you won't be right, even though it may say, why? They are imaginary. Yes, they are imaginary. But there is a term here that produces two imaginary. There is a term here and a term there. So they are not two. Do you see that? We have 4 imaginary roots here, not 2. They tell you specifically 2. They didn't say which one has imaginary zeros. And when I come here, which graph has imaginary roots? Of course, you know it. I'm not going to say it. And that's it for today. I hope it wasn't that bad. And again, if you have any questions about anything in imaginary, of course, we don't get deeper in this course in imaginary things because there is a lot of fascinating stuff about imaginary numbers. In fact, I may have one or other or more videos in the Mathematics Made Easy playlist that if you are interested, you can watch them that show you a lot of stuff that is really amazing when we use imaginary numbers. Having said that, I wish you all the best. If you have any comments, please leave me a note in the comments section and I will get back to you as soon as I can. Otherwise, I hope or I wish to see you soon. I wish you all the best. And until I see you back, have a great day.